Number 11 in 3.1 shows a graph that looks something like this. Boop, boop. Looks something like this, and it says what are all of the number of real and non-real solutions for this quadratic. Well, a solution was where does y equal 0? And since this never crosses the x-axis, y is never equal to 0, so this has no real solutions. And that means, since it's a quadratic, I would always expect 2, so that means there must be 2 complex solutions. So that's number 11. If I look at number 13, it says to plot. So for 13, the number it gives me is 1 minus 2i. If I plot that, this is the real axis, this is the imaginary axis. So since my real part is 1, I go over 1 on the real axis. Since my imaginary part is negative 2, I go down 2 on the imaginary axis. So this should be the point 1 minus 2i. Number 21. So then for number 21, it wants us to add these two. So it's this and 4i, and that's minus negative 6 plus 9i. This minus this. Okay, so what we're going to do is we are going to take this real part minus this real part. So this is really negative 4 plus 10. So that's going to be 6. Then the imaginary part is this minus 9i. So it's going to be, what, negative 5i. So it should be 6 minus 5i. The number 27 wants us to multiply two complex numbers. So we're just going to think of our complex numbers as binomials. So how do you multiply two binomials together? You simply FOIL, or distributive law twice. So negative 1 hits the first one, and then negative 1 hits the next term and gives us this. Right, then 2i hits the first term and gives me negative 4i. Hits the next term and gives me plus 6i squared. So when I multiply two complex numbers, I still get a complex number, so I have to rewrite it as a complex number. Well, since I squared is negative 1, then that means that this is just negative 6. So I have my 2 minus 6 is negative 4 for my real part, and then negative 3 minus 4i, negative 3i minus 4i is minus 7i. So this would be my complex answer. 35. 35 is dividing complex numbers. Well, they ask me to divide 3 plus 4i divided by 2 minus I. Well, I would expect when I divide a complex by a complex, my answer should be complex. So it should be of the form a plus bi. So to get it in the correct form, I need to make the bottom look nicer, so I multiply by the conjugate of the bottom. So in other words, I keep the same two terms, 2 and I, but I change the middle sign to a plus. When I do that, 2 times 2 is 4, and then I times I is I squared, and the middle terms cancel out on the bottom. That's because a minus b times a plus b is always the first one squared minus the second one squared. If you don't believe me, multiply it out for yourself. Well, then this and this give me on the top 6 plus 3i. And then this and this gives me what? Plus 8i plus 4i squared. So since this is just negative 1, then negative 1 is plus 1. So the bottom just turns out to be 5. Right? And then this turns out to be minus 4, since it's I squared is negative, and that's positive 4. The whole thing's going to be negative 4. So my 6 and a negative 4 combine to give me 2 on top. And then 3i and 8i combine to give me 11i. But that's still not a complex number, but I know that a plus b all over c is just a over c plus b over c. So this is 2 over 5 plus 11 over 5i. That would be the complex number I'm looking for. So now I look for number 37. So 37, I've got a negative 9 plus 3 square roots of negative 16. Well, negative 9 is just the square root of negative 1 square root of 3. Negative 16 is square root of negative 1 square root of 16. Sorry, this should be boop, boop, boop. I meant square root of 9. Okay. Well, the square root of a negative 1 right here is just I. And then the square root of 9 is just 3, so that's 3i. And this is 3 times I times 4. So we have 3i plus 12i, which is 15i for number 37. 41 is I to the 8th power, but that's just I squared to the 4th. But I squared is negative 1, so negative 1 times itself an even number of times, it's just a positive 1. Then, relatedly, 43 is I to the 22nd. Well, that's just I squared to the 11th. So it's negative 1 times itself an odd number of times, which is negative 1. Okay, then we're looking for 53. So these are just a little bit uglier. So 53 is 2 plus I, times 4 minus 2i. All that divided by 1 plus I. So I'm going to come over here in my scratch work, and I'm actually just going to work out this top part. So I'm going to hit copy, and I'm just going to do it over here on my scratch work. So that should give me, when I distribute, what, 8 minus 4i and minus 2i squared. It's going to be the last term. It's going to be plus 4i. Plus 4i. So minus 4i plus 4i. Those cancel. We'll just get 8. Well, this is minus 2i squared. So that's really just plus 2. It's 8 plus 2, which is 10. So the top is a fancy way of writing 10. So I have 10 divided by 1 plus I. To actually do that division, I need to make it look nice by multiplying by the conjugate. So I take the same two terms, but change the middle sign on the bottom from a plus to a minus. So this thing right here is called a well-chosen one. All this is just equal to 1. So it's going to look different, but still be equivalent. So on the bottom, you end up getting, what, 1 squared minus I squared? But 1 squared is 1, and I squared is negative 1. So this is negative 1, or plus 1 is what that really is. So, boop, boop. So this is just plus 1. And so on the bottom, I get 1 plus 1, which is 2. And the top, if I distribute, I get 10 minus 10i. So then 10 minus 10i is the same as 10 divided by 2 minus 10 divided by 2 i's. So that's 5 minus 5i. For our last question, it's 55. It said you can take 3 plus I and square it, divided by 1 plus 2i and square it. So I would maybe distribute out the top, get 9 plus 6i plus I squared. On the bottom, distribute it out, and you get what? 1 plus 4i plus 4i squared. So since that is just negative 1, and this is just negative 4, I really have negative 1 and 9 gives me a real part of 8 plus 6i for my imaginary part. And then since this is just negative 4 and 1, on the bottom I have negative 3, the real part of plus 4i. So now I have a complex number divided by a complex number. I know I need to use my old body, the conjugate. So I keep the same two terms, a negative 3 and a 4i, but I change the middle sign only. When you do that on the bottom, I get the first one squared minus the second one squared all over. And then on top, I guess I'm going to do the distributive law. So this hits this and gives me negative 24. That gives me negative 32i. Then these hit each other and give me negative 18i. And this hits that, gives me negative 24i squared. So negative 3 times negative 3 is positive 9. And then 4i times 4i is 16i squared, which is negative 16. Then make it negative, so this is really plus 16 on the bottom. Because if that's negative 16 and then you subtract a negative, it's the same as plus 16. So the bottom is really just 25. And on top, this is just a positive 24 right here. So positive 24 and negative 24 actually cancel each other out. And I get what? 40, 50. I get negative 50i on top. And so that's just negative 2i. And that's it. Great work. See you next time.